separation confirmed. Landing burn.
Successful spacecraft separation.
Cygnus capture complete.
Welcome to ISS, Cygnus.
On your screen is a view of Falcon 9 scheduled to launch from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida in just over 17 minutes. Today's mission is SpaceX 74th of 2024 and the 5th mission to the International Space Station this year, following Crew 8, CRS30 and G20 and X3. This launch marks Northrop Grumman's 21st Commercial Resupply Services CRS mission to the ISS. The spacecraft, named SS Francis R. Scobie, honors the late commander of the Challenger STS-51L mission. The Falcon 9 rocket, designed and manufactured by SpaceX, is a reusable two-stage vehicle. It has supported ISS operations since 2012, delivering critical science hardware and supplies to date. SpaceX has conducted 73 launches this year, averaging one every 3 days, and aims to achieve up to 148 missions in 2024. The Falcon 9 is currently the only orbital class rocket capable of flight. The payload fairing, which protects the payload during launch, will separate once the rocket launch reaches space, exposing Northrop Grumman's Cygnus spacecraft.
Thank you, Zachary, and good morning to everyone from the International Space Station Flight Control Room here at the Johnson Space Center in Houston, Texas. It's a full house aboard the International Space Station with 9 crew members living and working at the orbital outpost. The Expedition 71 crew, who you see now, are being led by Station Commander Oleg Kononenko. But the focus of attention today on the Falcon 9 launch of the SS Francis R. Dick Scobie Cygnus cargo craft, named after the late commander of the Challenger STS-51L mission. Scobie served as pilot aboard Challenger on STS-41C in April of 1984, which retrieved, repaired, and redeployed the Solar Max science satellite. He was then the commander of the ill-fated Challenger STS-51L mission in 1986. Northrop Grumman's resupply vehicle is poised to deliver roughly 4 tons of science, experiments, and equipment to the orbital outpost. After Cygnus separates from the upper stage of Falcon 9 today, the spacecraft will conduct a series of engine firings to increase its altitude to match that of the International Space Station. That will set it up for the start of joint operations between Northrop Grumman engineers in Dulles, Virginia, and the NASA Flight Control team here in Houston. A launch today will bring Cygnus to the station in the morning hours Tuesday, where NASA astronauts Matt Dominic and Jeanette Epps will be waiting in the cupola, set to use the station's robotic arm to reach out and grapple the spacecraft. That will be installed to the Earth-facing berthing mechanism on
first commercial resupply services mission to the International Space Station, carrying science to further NASA's missions to deep space and benefit life on Earth. A packed bed reactor will test how microgravity affects the simultaneous movement of gases and liquids. Results will aid the design of various space systems, including life support systems. Researchers will continue testing a technology to produce stem cells in space, aiming to improve outcomes for patients with certain blood diseases, autoimmune disorders, and cancers. Microscopic organisms will travel to station to provide crucial insights into how spaceflight affects the ability of damaged DNA to repair itself. Demonstrations are educational videos demonstrating STEM topics in space for students on Earth. For this mission, astronauts will use a balloon, a penny, and a hex nut to examine centripetal force. Discover more about all of the science making the journey to the orbiting lab at nasa.gov/ISS-science.
Currently, the weather is 35 favorable for launch. If the launch does not proceed today, there is a backup window on August 6th. Stage 1 RP1 loading is complete. The second stage RP1 loading is nearly finished. Engine chill began at T-7 minutes and liquid oxygen loading is underway on both stages, expected to complete around T-2 minutes. The Cygnus spacecraft is carrying approximately 4 tons of supplies and scientific experiments to the ISS. The mission includes observing blood vessels development in engineered liver tissues, evaluating fluid dynamics through porous media, demonstrating the production of blood and immune stem cells, and studying the effects of microgravity on DNA repair. Educational demonstration will also be conducted to teach STEM topics to students on Earth. As the countdown continues, the strong back structure next to the rocket is retracting to clear the way for launch. Final pre-launch checks and vehicle health confirmations will occur at T-30 seconds, followed by ignition sequence starting at T-15 seconds, leading up to liftoff at T-0. Currently at T-6 minutes and 20 seconds, all systems are nominal with no significant issues reported. Liquid oxygen loading will complete around T-2 minutes. Stay tuned for live updates as we approach the launch. We are currently loading helium gas in both stages to ensure smooth engine startup. SpaceX performs a procedure called engine chill, where a small amount of super chill liquid oxygen flows into the main engine turbobomb. This prevents thermal shock to the propulsion system when the full flow of super chill liquid oxygen is introduced into the Falcon 9 plumbing. Additionally, SpaceX is conducting final health checks as the rocket prepares to switch to the internal battery power, with all the activities monitored by the Northrop Grumman flight controllers in Dallas, Virginia. Shortly, the transporter erector TE will retract from the Falcon 9 rocket. The T is the large structure next to the rocket. As it moves away, the clamp's arms around the second stage will open. The T will pull away from the rocket by a few degrees liftoff to provide clearance for this vehicle. We should see the clamped arms open around the vehicle second stage within 20 seconds. The strong back retraction has begun and fuel loading continues. The Falcon 9 fuel comprises a propellant and an oxidizer, refined kerosene called rocket propellant 1 (RP1), and liquid oxygen LOX. The clamp arms are opening around the second stage, and the strong back is moving away from the vehicle. The white clouds around the Falcon 9 are caused by the venting of the chill gas from the LOX tank, which condenses into clouds when exposed to the warm Florida air. Today's mission involves the booster, which is flying for its 10th time. The soot visible on the rocket skin is residue from the carbon-based fuel deposited during re-entry. Stage 1 LOX loading is complete, and the second stage thrust vector control actuators are undergoing a double test to ensure proper guidance hardware functionality. This test checks the nozzle's movements on the first stage just before ignition. Falcon 9 is in startup mode, and the Cygnus is transitioning to internal power. The rocket computers are performing final pre-launch checks, and both stages are being pressurized for launch. The range remains green for launch. The countdown reaches T-30 seconds, then moves to T-15 seconds. Ignition starts at T0 with full engine power and liftoff at 18:07 UTC.
Falcon 9 is in startup. LD is go for launch. T-minus 30 seconds. T-minus seconds. Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. We have liftoff. Go SpaceX. Go Starlink.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
We have achieved successful lift-off from Space Launch Complex 40 with power and telemetry readings nominal. In about 20 seconds, we will hear the call out for max Q, which is the point of maximum aerodynamic pressure. This is when Falcon 9 experiences the highest aerodynamic stress due to its speed and air density.
Telemetry.
Following max Q, we will experience 5 key events in rapid succession. Main engine cutoff, MECO, stage separation, second engine start, SES1, boost back burn, and fairing separation. MECO is when all 9 Merlin engines on the first stage shut down. Stage separation follows where first and second stages of Falcon 9 separate. A few seconds later, the Merlin vacuum engine on the second stage will ignite to boost Cygnus to low Earth orbit, known as SES1. The first stage will then reorient itself for landing, and 2 fairing halves will separate to expose the spacecraft.
Max Q.
Stage 1
Terminal
transonic.
guidance. Vehicle is on a nominal trajectory.
Main engine cutoff. Stage separation confirmed.
We have confirmed main engine cutoff. Stage separation, SCS1, boost back burn, and fairing separation. The next step is completion of the boost back burn, which lasts about 50 seconds. This burn is crucial for redirecting the booster back to landing zone 1 at Cape Canaveral Space Force Station.
Fairing separation confirmed.
This is SpaceX's 74th mission of 2024 and the 5th flight to the orbiting laboratory this year. The Falcon 9 stage will now execute 2 more burns to return to Earth. The entry burn, where 3 Merlin engines will reignite to slow the stage down during re-entry, and the landing burn, which rapidly reduces speed for landing. During the re-entry burn, the Falcon 9 will decelerate by firing its Merlin engines, causing the rocket to pass through the exhaust gases and ignite soot on its surface. This soot is from the carbon-based fuel used in each flight. On the left side of your screen, you can see the Falcon 9 first stage as it returns to Earth.
Boost back shutdown.
On the right side of your screen, you can see the Merlin vacuum MVAC engine of the second stage, which is currently carrying Cygnus into orbit. The Merlin engines on the first stage are optimized for sea level, providing 190,000 pounds of thrust during each both ascent and descent. In contrast, MVAC engine, which is larger nozzle, is optimized for vacuum conditions and delivers 22,500 pounds of thrust. On the left side of your screen, you can spot the Falcon 9 4 hypersonic grid fins, positioned near the top of the first stage. These grid fins are used exclusively for steering the rocket during its return to Earth, helping to orient the rocket during re-entry and guide it back to the surface. We are now seeing beautiful views of MVAC engines as it continues to carry the Cygnus spacecraft towards orbit. Occasionally, you might notice small white puffs from the booster on the left side of your screen. These puffs are nitrogen gas bursts used for altitude control. In about 10 seconds, we should hear the call loud for the Falcon 9 first stage entry run. Both vehicles are following nominal trajectories. The entry burn for the first stage has now started, and we have received confirmation of its successful initiation. The entry burn for the first stage has completed, and the call loud for the end of this burn has been confirmed. The stage is equipped for landing legs made from the state-of-the-art carbon fiber and aluminum honeycomb material, which deploy before landing. If successful, this will be the 10th recovery of this particular booster and 335 successful landing on the first stage booster since SpaceX's first successful landing in 2015.
Both vehicles are on a nominal trajectory.
Stage 1 NG burn. Stage 1 entry burn shutdown. Stage 1 FTS is safe. Stage 1 transonic.
The landing burn for stage 1 is underway.
Stage 1 landing burn. Stage 1 landing leg deploy.
The Falcon 9 booster has successfully landed at landing zone 1,
Landing confirmed.
marking its 10th flight and 335th successful landing of the first stage booster.
Stage 1
Terminal
transonic.
guidance.
At around 8.5 minutes into the mission, we should receive the call out for second engine cutoff SECO, indicating the shutdown of the MVAC engine on the second stage. This will conclude the approximately 6-minute burn required for the spacecraft to be placed into proper orbit. We should hear the call out shortly.
MVAC shutdown.
The SEC-1 call-out has been confirmed, and we are now waiting for confirmation of successful orbital insertion.
Nominal orbit insertion.
The call-out for nominal orbital insertion has been received at T-9 minutes into the mission. The second stage next major task is to command the space separation of the Cygnus spacecraft in just a few minutes. The call-up for Cygnus payload deployment is expected in about 25 seconds. Payload deployed confirmed. This commercial resupply mission surfaces CRS mission to the ISS is SpaceX's 74th mission of 2024 and the 5th flight to the ISS this year. Following separation, Cygnus will begin its nearly 40-hour transit to the ISS, where the station's Canadarm2 will grab their spacecraft and attach it to the Unity module Earth-facing port for cargo and loading by the Expedition 71 crew. That wraps up our coverage for today. Thanks for watching, and we'll see you next time. Channel and activate the notification button. This is Sammy Space. This is Space Network.